Hello class, in this lesson I will be more or less sketching or giving you the layout of the solution to these four problems in the portfolio because we haven't talked about these types of problems in regard to quadratic equations. So I want to do this for you, okay, as the last lesson of the semester. I'm not going to be solving these problems completely, but only about 40 or 50%. Okay, the arithmetic, the algebra is going to be left to you. So let's start. Okay, in this first problem we have the following. Oh, and by the way, let's read the instruction. The instruction says, for the following exercises, you will need to design a model that represents the situation. They forgot to write it here. And solve the equation. Check for the corresponding units. By the way, I didn't write this sentence, so I need to say the following. What the person that wrote this meant by a model, okay, by these guys, what that means is basically like the mathematical model. You see, in here you have a situation, and in here you have another situation. They can be from real life or from highly hypothetical and mathematical scenarios, and you have to model. You have to model these situations mathematically. What that usually means, guys, is basically writing down an equation that represents what's happening in the problem, right? For example, if I tell you that my age is 10 years more than my brother's age, this is me, Nestor, and my brother's name is Rafael, and therefore the model, or the equation that represents what I just said is this: n equals r plus 10, right? My age is my brother's plus 10. You see, that's what the model means. That's what this thing means. It's basically set down an equation that represents the whole things that you're talking about. So let's see. The difference between two positive whole numbers is 6 units, and the sum of their squares is 218. What are these numbers? Okay, remember, the first thing is this. Label those numbers. Okay, say something like this. I'm gonna define A and B. The first number of these two that they're talking about, and B is the second number. Okay, I'm defining my variables, and then they tell me the difference between these two numbers is 6 units. That can either mean that A equals B minus 6, okay, or that B equals A minus 6, right? Both of these things are saying this thing, guys. Okay, and we're gonna check, like, is it possible to do the problem taking this branch or this branch, because they're not the same, right? In here I'm saying that A is greater than B because A is equal to B minus 6, and in here I'm saying that B is greater than A. You see what I mean? Now the other way around, I'm sorry, A is less than B, and in here I'm saying that B is less than A. But uh, let's go with this one first. Let's go with this one. So we have this, and then we have the sum of their squares is 218. So the sum of the squares of these variables is 218. Okay, this is one equation, guys. I'm gonna label it as equation 1, and I'm gonna label this as equation 2. And that's it, guys. This is what is known as my model. It's basically two equations representing all of these things said in these sentences. What are these numbers? Let's find A and B. What do we do? It's a system of two equations with two variables. In this case, they are not linear equations. I mean, at least not this one. This is not a linear equation, right? So you cannot use the method of elimination, the method of addition and subtraction. You cannot use it here. But you can use the substitution method, right? If you know that a is equal to this, then all you have to do using the substitution method is input this value in here, such as in this way: b minus 6 to the square plus b squared equals 218. You see, instead of writing a to the square, I wrote b minus 6 to the square, because b minus 6 is equal to a. And then we have this equation, right? If we expand this binomial, we get this. Right? And then what we have in the end, it's a quadratic equation that you can solve by any method you want, either the general formula or completing the square. Maybe this is not going to be possible to solve through factorization. Maybe it is possible. You have to check that out. But all that needs to be done at the moment is solving this equation, and you're going to be getting b. And after you get b, you can get a. Okay, so that's how you solve this problem. And if you notice, I erased the other possibility, right, of b being equal to a minus 6. When you solve it by using this other branch of the possibilities, because I repeat, guys, both this and this equation represents this idea that the difference between two positive whole numbers is 6 units. Both of these, okay? If you solve the whole procedure with this one, you're gonna get the same answers, but only interchanged. So for example, if in here you get 16 and 10, if that's what you get in here, then if you do it with this other approach, you're gonna be getting b equals 10 and a equals 16. You see what I mean? That's the only difference between following this one, between writing this one or writing this one. Okay, that concludes this problem. As I repeat, you can be doing the rest on your own, the solution to the equation. I'm not gonna be doing that. This one, the sides of a rectangular land are given by the expressions x minus 5 and x minus 7 meters. So let's write that down. This is my rectangular land, and we have x minus 5 and x minus 7. Determine an algebraic expression that represents its area. So the area of this land is clearly side times side. So this is what you get. And once the expression has been obtained, what are the measurements of the land so that the area is this much? Okay, so basically they're telling me that the area is, I know that the area is this much, 1,760 square meters. So let's put that in here, 1,760 meters, square meters, and continue writing the equation, right? Okay, and then after this, if we continue on the right side, after you multiply these two binomials, you're gonna be getting a quadratic equation, right? X squared, and then we'll have minus 12x plus 35. Okay, this is a quadratic equation. Let me put it in standard form. Remember, what is the standard form of a quadratic equation? Is when you put the whole thing like this. First the quadratic term, then the linear term, and then the constant term. After I bring this one to the other side as negative, because I'm going to be subtracting this value from both sides, you're going to be getting minus 1,725, if I'm not mistaken. Yes, that's right. So this is it, guys. Okay, this is the question that you're going to be solving. preferably through the general formula so that you don't get into too much trouble. And you can use a calculator, it's perfect. So after you do the solution, you're going to be getting the possible values of x. Okay, and by the way, if one of these is negative, you have to reject it, right? Remember, this is a quadratic equation. It has two solutions. It must have two solutions. But in this context, if one of these solutions is negative, you have, let's suppose this is the one that is negative, negative 10. Let's suppose. Then you need to reject this and only accept the positive solution. Why? Because it makes no sense to have negative sides. For example, if this was minus 10, and if you plugged this in here, you would be getting minus 10 minus 5, that's minus 15. So you would be saying that this side measures minus 15 meters, and that makes no sense. That makes no sense. So you only have to accept the positive one. If both are positive, then what that would tell you is that both possibilities are perfectly acceptable, okay? And you have to follow the rest of the problem, which is what is the perimeter of the land, by using first this solution and then this solution, right? Um, and so that's it, guys. That's how you solve this one. The next, the base of a triangle is 5 meters greater than the height. So let's draw a triangle. They don't tell me what type of triangle this is, so let me draw whatever triangle I want. I'm gonna draw this general triangle. There you go. This is the base, this is the height, and the base of the triangle, which I'm gonna label as B, and this is the height. Okay, and we know that the base, let me put it over here, the base is 5 meters greater than the height. So I know this, that the base is equal to the height plus 5. I am translating this into a mathematical model, an equation. If the area of the triangle is 102 square meters, what are the dimensions of the base and the height? What is the base and what is the height? If I know that the area of this triangle is 102 square meters. Okay, so all we need to know is the formula for the area of any triangle, which is base times height over 2, right? And I know that A is equal to 102, so I can make that substitution in here, right? And then I have this equation 1, and this equation 2. Both of them contain B and H as variables. So once again, I need to solve this system of equations, this equation and this equation, by substitution. In this case, once again, we already know that the base is equal to the height plus 5. So I'm going to make that substitution in here. And what you will get is this 102 equals the base, which is H plus 5. So let me make that substitution, times H over 2. We continue. I multiply both sides by 2. You get 204 equals, I multiply these two factors and you get h squared plus 5h. I put this quadratic equation in standard form, which is h squared plus 5h minus 204 equals 0. And once again, you obtain a quadratic equation that you can solve using general formula or completing the square, anything you want, and you're gonna be getting the the magnitude of the height for this particular triangle. And once you obtain the height, you're gonna put it in here, you're gonna add 5, and you're gonna be getting the base. Done. Period. And this one, the base of a right triangle. So now they're telling me specifically that we are working with a right triangle, un triángulo rectángulo, you see, so it has a 90-degree angle in here, and they're telling me that the base of this triangle is 2 meters greater than the height. This is the base, this is the height. Base is equal to height plus 2 according to this sentence. And we know the area, once again, it's pretty much the same problem. The area is 100. It's the same problem, guys. It's the same. It's the same as before. There really is no difference. The fact that this is a right triangle makes no difference, right? Because the formula for the area of this right triangle is still b times h over 2. And you do exactly the same stuff we did in the first one. So that's it, guys. I was just explaining to you the outline of these problems, and you solve them on your own. Probably you already solved them anyways. So thank you, guys.